Tenacious coders, welcome back to another lesson in CircuitPython School. This is Prof G, and in this lesson we're going to cover for loops and ranges, concepts you'll use all the time as you program, and that will greatly increase the efficiency and elegance of your code. So let's learn! So our one blue at a time looks real pretty, but if you take a look at our code, it looks like we've got a bunch of lines that are repeated, and in fact the only thing that seems to be changing is the index value for our pixels. And you might be wondering, hey, is there a way that I can iterate through or loop through these 10 values? And there is! Behold the majesty of the for loop! Now, like the while true loop, the for loop has indented code beneath it, and we repeat that indented code or loop through the code, but instead of being in an infinite loop like while true, we instead go through the loop the number of times indicated by the range. Now, the range here says 5, so that means that we're going to go through the code down below 5 times, and then we'll stop and we'll continue with any code that's below this that isn't indented. Now, because we're 0 indexed, remember, we're going to start counting at 0, and we'll go through 4. We never reach 5. So we do go through the loop 5 times, but we start at 0, go 1, 2, 3, 4, and never reach 5. So if there's one number in here, it means start at 0 and go up to, but never reach this value. Now we have another value in here named index. We could have given this any other name, just like we name variables, but the most common names that you'll see here are index or I or X. And the first time we go through the loop, index's value is going to be 0. And we can use that value, index 0, in any of the code that's indented. So for example, when we print index, we print 0. When we do pixels at the index of index, we're going to light up the first pixel in purple. Then the second time we go through the loop, index is going to be 1. So we print 1 and we light up pixels 1. The third time it's going to be 2, fourth time 3, fifth time 4. So you can see by using the for loop this way on the range 5 and by referencing the index inside, we print out the values from 0 through 4 and we light up pixels 0 through 4. This is super handy, it's very powerful, the for loop will be a staple of your own Python code, so let's give this a try in the REPL. So let's open the serial console, type Control-C, press any key, and now I'll type the first line of a for loop. So I'm going to say for, and remember I said that you could name that index value anything. So I'm going to change the name to I here, just to show you that you can use any valid variable name as the name for your index. And then I'll say in range, and in parentheses, the range will be 5. That means we start off at 0 and we go up to, but we don't reach 5, and then colon, and then press return, and you see that we're indented. Now the cursor at the left with the 3 chevrons turns into 3 periods. That just means that the REPL recognizes that you're entering a loop at this point, and it's going to keep everything indented until we press return and then press the delete key. And it won't execute this entire block of code that you're entering that's part of the for loop until you press that delete key and this prompt with the 3 periods on the side goes away. So right now all I'm going to type in is going to be print and then in parentheses I. I could put more indented lines of code below here, but let's just start with the print statement. I'll press return, then I'll press the delete key, and when I press return one more time, look what happens. The code executes, and you can see we've gone through the loop 5 times. The first time I is 0, second time 1, third time 2, fourth time 3, and fifth time 4. Nice work, your first CircuitPython for loop. Now time for a challenge. We're going to enter the challenge solution as a program, so let's Control-D to get out of the REPL and close the serial console. And your challenge is to repeat the one blue at a time challenge from the prior video, but this time use a for loop to minimize the amount of code that we need to write. And as a reminder, your code should light up each light in blue, pausing 1/10 of a second after each light is turned blue, and then when all the lights are blue, turn them all off, wait 1/10 of a second, and then restart the pattern from the very beginning. So why don't you pause, give this a shot, resume, and let's see how you did. First, I'll modify the comment up top to indicate that this is the one blue at a time with a for loop. Then I want my for loop to continue inside of the while true loop. The for loop is going to go through the range 10, 0 through 9, but when it's done, I want to go back to the top of the while true loop and restart the for loop over again, going through 0 through 9 again. So you see that? We're going to have a loop inside of a loop. And I entered this loop in here as for x in range in parentheses 10 with a colon. Instead of x, I could have used any valid variable name. Now when I press return after the for loop, you notice that I'm indenting here. Now all of the lines that are indented underneath the for loop are going to be part of the for loops. So that's going to be the group of lines that I repeat 10 times, incrementing x each time I go through the for loop. Now I'm going to highlight, cut these 2 lines here and move them inside of my for loop, because each time I go through the for loop, I want to light up one of the pixels, and then I want to sleep for 1/10 of a second. I'll fix this indent so that time sleep is also indented. And then I'm going to change the index value here. It's not going to be pixels 0, it's going to be pixels x. So I'll go through this block of 2 lines here, and I'm going to increment x starting at 0 going up to 9. And since my for loop takes care of lighting up all of the pixel lights from 0 through 9, I can delete all of these other references to pixels 1 through pixels 9, as well as the time.sleep that's after them. Now I'm going to keep these last 2 lines outside of the for loop. Notice how they're not indented with the other 2 lines that are part of the for loop. Now these 2 lines execute after the for loop has completed all 10 of its loops or its iterations. And only then, when all 10 lights have been lit up, do I want to turn the lights off and then wait 1/10 of a second more. Then I go back to the start of the while true loop, and then I begin the execution of the for loop again, restarting with an x value of 0. So now let's open the serial monitor and save this, and our code executes. The code does the exact same thing as the previous code does, so we don't see much of a change here on our CPB, but we do see that we don't have any errors. The most important thing is look at how elegant and compact our code is when we use a for loop. We were able to eliminate all of these extra lines from the previous solution and instead accomplish the bulk of what we wanted to do right inside these statements in the for loop. Nice! And we know this is working because we didn't get an error, but if you wanted to change the default color from blue to green and then save and run again, we can see again the CPB changes to green. Everything's working great. And I'll just change the green back to blue. And as you look at this code, you might be saying, well, that's really great from going through 0 to 9, but what if I wanted to go through a different range? Let's say from index 5 to 9, so that I could light up just the second half of the CPB. Well, my friends, you can do that with a Python range that has 2 numbers in it. Now, the first number is the number that you start at, and the second number is that number that we go up to, but we never reach. If we have a for loop with a range 5, 10 and we run it, we see that we start 5, 6, 7, 8, 9, and we can use that to light up the second half of the CPB. So let's head back to the REPL. We've got a REPL with a cause now to try out our for loop with a 2-number range. So open the serial monitor, Control-C, press any key. I'm going to highlight and copy these 4 lines above that set up my code, paste them in, and then we'll write our loop for index in range, and in parentheses 5, 10. So start at 5, go up to, but don't hit 10. Then I'll put in a colon, press return. I can see that I'm indenting here, and I'll type pixels, and then in brackets, index equals, and why don't we light these up in red? So in between parentheses, 255, 0, 0, press return. We'll stay indented, time.sleep, and why don't we do this at half a second, 0.5 in between the parentheses. Then press return, press the delete key, and return. And would you look at that? We're going from 5, 6, 7, 8, 9, all in red. Nice! You now know how to use a Python range with 2 numbers. Next, you might wonder, could I go up but skip values? Maybe loop through and light up every other value? Yes, my friend, you can. That's where the 3-number Python range comes in. First, we have our start number. Second, we have the number that we go up to but we don't reach. And the third value is the increment value. So in this example, if we go through the range, we would start at 0, we would go up to but never reach 10, so we would stop at 9, and the 2 means we count by 2, so we would do 0, 2, 4, 6, and 8. Why don't we try this out ourselves in the REPL? First, so that we can start out fresh, I'm going to shut off all the lights with pixels.fill, and then in double parentheses, 0, 0, 0. Then let's enter our for loop as for I in range, and then we'll have our 3 values as 0, 10, 2, colon, press return, and we'll say pixels in brackets I equals, and let's set this up in between the parens as green, 0, 255, 0. Then we'll do a time.sleep, and in parens 0.1, so that's 1/10 of a second. Press return, press delete, press return again, and look at that, lighting up in green, 0, 2, 4, 6, and 8. Good work! Now if you can go forward by 2, I wonder if you can go backward by 2 or backward by 1. What do you think? Well, as they say in Espanol, si se puede, or yes we can. That's also a range with 3 numbers. All we need to do is start with a larger number, then we're going to go down to the smaller number. Remember, we go up to, but we never go past this number. And that third number is a negative value. That's our increment value. So if we try our example here, we're starting out at 8. We're going to go down 2, but we're never going to reach -1. That means our last value in the loop is going to be a 0. And our increment is going to be by -2. So we start at 8, 6, 4, 2, and 0. Let's go give this a try in the REPL. First, let's shut off all the lights in the CPB with pixels fill 0, 0, 0. Then we'll try this example with 4x in range, and in parentheses 8, which is our start value, comma, -1 will go up to, but we won't reach that, so the last value will be 0, comma, -2 will go down by 2, close parentheses, colon, press return, and indented into the for loop. Why don't we light them up in blue with pixels, and in brackets x equals, and in parens 0, 0, 255, and on the next line, let's sleep by 0.2 of a second, time.sleep, in parens 0.2, press return, press delete, press return again, and looking good. Going backwards now by 2s. We've just turned on blue the lights in the position of 8, 6, 4, 2, and 0. Nice work. Now let's go backward by 1 just to make sure we know how to do it. So I'm going to fill with 0, 0, 0. Then I'm going to use my up arrows to fill out this next example, 4x in range. And I'm going to change the 3 values in the range to 9, -1, -1. And why don't we light them up in red this time, 255, 0, 0. But we'll keep our time sleep at 0.2 of a second. Press return, delete, press return again. And look at that. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We got all 10 lights lit up, but in the opposite direction. Nice work. And now it's time for 2 challenges. I'm going to leave you to do these challenges on your own. The first one is going to be the challenge to turn them on, then turn them off one by one. So we're going to light up all the neopixel lights on your CPB board individually in any color you like. I'm going to use orange here, starting with light 0 and then ending with the last light, waiting 1/10 of a second after each light has been turned on. Then when all the lights are turned on, turn them all off one by one, starting with light 9 all the way down to light 0, waiting 1/10 of a second after each light has been turned off. Once all the lights are turned off, wait another 1/10 of a second and restart the pattern. So if you've implemented this properly, this is what it should look like. You're turning on the lights one by one, then you turn them off one by one, and then you restart that pattern. Give it a shot, Python programmer. I know you can do it. And then when you're done with this, we've got another challenge for you. Now our last challenge is to use a new neopixel property. That's the brightness property. Now you can change the brightness of all of the neopixels on your board by using .brightness. So for example, if you say pixels.brightness equals 1.0, that will set the brightness of the neopixels to 100%, while pixels.brightness equals 0.0 is going to set the brightness of the pixels named pixels to 0, meaning the lights go off. Now in this challenge you can fill in with any color you'd like. You'll see that I use blue in this demonstration, but then use a for loop so that you pulse from 0 to 100% brightness, going up 1% at a time and waiting 1/100th of a second after each increment. So this is a smaller time increment than we've ever used before. Now once you're at full intensity, then you want to return from 100% back down to 0%, waiting 1/100th of a second after each percentage decrease in brightness. Then you want to repeat this continually, so pulsing up and then down, full brightness, then off, full brightness, then off. Now here are your hints. For loop ranges only take whole integers. Interesting. So these values won't work because they have decimal points in them. You can't use numbers with decimals, but you can perform math on any number passed into brightness. So think about the math that you would perform to take whole numbers and turn them into 0.0 to 1.0 as your start range and your end range. And remember, in order to reach this value, you want to go 1 past this value. Now you already know the operators for performing basic math functions. They're the same that you'd find in Excel: plus, minus, multiplication, and division. This is how your CPB should pulse when things are working. So from completely off to completely on, then back off again, then back on again. The entire pulse up should take 1 second and then 1 second to go down. I know you've got the skills to do it, programmer. Give it your best shot. And hopefully those challenges will go well for you because we once again had big learning in this lesson. We introduced for loops. For loops in the REPL, how to do single value ranges, 2 value ranges which were start and end value, and 3 value ranges which were the start and an increment value, and we moved forward and backwards in the range. I hope you feel those CircuitPython skills are building. There's lots more to come, so keep at it.